Okay, so we're going to continue where we left off here, where we had a polynomial defined, negative 3x plus 1 squared plus 4, and we want to find the vertex, we want to find the x and y intercepts, we want to find the domain and range, and we want to find any maxes or mins, and we want to graph. So remember that our standard for our vertex form is the following. It's p of x is equal to a times x minus h squared plus k. So we can see here that h is actually minus 1 and k is 4, because the middle here can be written as x minus 1 squared plus 4. So h is this guy right here, and k is this guy. So our vertex then is the point negative 1, 4. So, and our a value, this a is minus 3. That's negative, so that's less than 0. So we're going to have a downward pointing parabola. And so let's go ahead and graph it. That's enough information to at least get the basic graph. Well, actually, I guess let's get our intercepts as well so we can label those. So let's compute our x-intercepts. So we have negative 3x plus 1 squared plus 4. We have to set that to be 0 and solve for x. So we have negative 3x plus 1 squared is equal to minus 4, or x plus 1 squared is equal to 4/3, or x plus 1 is plus or minus the square root of 4/3. So x equals negative 1 plus or minus the square root of 4/3. And these are our x-intercepts. Of course, this is where y is 0. And our y-intercept, we set x to be 0, so we get negative 3, 0 plus 1 squared plus 4. So this is negative 3 plus 4, which is 1. So let's use these values. So we have negative 1, and then 4 is somewhere up here, and then 1 is somewhere here. And then so our graph will look something like this, where this point is the point, so let me label with a different color. This point is the point 0, 1, and then our x-intercepts, let me label with the green color here. This would be negative 1 plus root 4/3, comma 0. This would be negative 1 minus root 4/3, comma 0. And this is your vertex, of course, which I'll just label there, negative 1, 4. And you can see visually that the max value of p of x is 4, and it occurs at x equals minus 1. That's the maximum value. There's no minimum value. All right. Last but not least, the domain and range. Well, again, I said the domain of any polynomial is always all real numbers. It's in everything. The only question is the range. Well, in this case, it's the maximum value is 4, so the range will be everything up to 4. So negative infinity to 4. And that's the exercise at the end of the last video. What's left is now to convert, so we have to now just, the last part of this is to convert from a regular polynomial, or just a general form, ax squared plus bx plus c, and how do we go from there to the vertex form, which is the a times x minus h squared plus k. So what we're going to do is we're going to do some work on that. So let's do an example just of that part, because the rest of it, I think, hopefully we have some ideas about. So let's say p of x is 2x squared minus 12x plus 10. And let's just say we want to convert to vertex form. And maybe once we're there, we'll see if we want to do the rest of the, the domain and the range and all that stuff. But let's just start with doing the vertex form. And how are we going to do that? We're going to complete the square. That's going to be the method. So how do we do that here? Remember that we have 2x squared minus 12x. We're going to just leave out the constant term alone off to the side here, so that it's, because it's not going to play a part in the algebraic process, at least not initially. So what do we do? Remember, when there is a non-zero or a non-unit term here, a number different than 1, we have to factor that out. So step 1, let me just write that maybe off to the side here. So step 1, factor out the lead term. So this 2 is also this highest degree term, the square term. The coefficient is called the lead term, which is just 2. So let's do that. This becomes 2 times x squared minus 6x. I'm going to close parentheses a little bit away, plus 10 here. So let's take a half of this negative 6 and square it. So step 2, take 1/2 of negative 6, which is negative 3, and then we're going to square it. So it's going to be okay. That's what we're going to add and subtract. So plus 9 minus 9. This is equal to 2. And remember, the part where we just do the addition, that part forms a nice factorization. So it's going to be 2 times this whole quantity. And then it's going to be 2 times this constant. So that's minus 18 plus 10. So we're going to get 2, and then this factors to x minus 3 squared, noting again that this negative 3 corresponds to that negative 3, and then minus 8. So now we have successfully put this in vertex form. So this is the vertex form. Okay, I guess let's just finish up by doing the rest of this, the usual. So we're going to find the vertex. We're going to find in this case, the minimum value. So you can hopefully see the correspondence that if a parabola is pointing upward, you only have a minimum value. If it's pointing downward, you have a maximum value. So we have the vertex, the minimum value, x and y intercepts, and then domain and range. So the vertex here is 3, negative 8, where the minimum value is exactly that y value right there, negative 8. So the domain is all real numbers. The range, well, it's going to be the minimum value off to infinity because we're going to get an upward pointing parabola. Okay. So the only thing left is the x and y intercepts, and we'll graph it. So for the x-intercept, we set y to be 0. So we get 2x minus 3 squared is equal to 8, or x minus 3 squared is equal to 4, dividing both sides by 2. And hence x minus 3 is plus or minus the square root of 4, which is plus or minus 2. So x minus 3 is plus or minus 2. So x is 3 plus or minus 2. Well, 3 plus 2 is 5. 3 minus 2 is 1. So we can compute this nicely. These are our x-intercepts. For the y-intercept, we have p of 0. We plug in 0. We get 0 minus 3 squared minus 8. 9 times 2 is 18. So 18 minus 8 is 10. And so we can graph in the following way. We had our vertex of 3, negative 8. So 1, 2, 3, and then somewhere down here is negative 8. We have an upward pointing parabola. Well, the y-intercept is right here at 0, 10. We have x-intercepts at 1 and 5. So we're going to get something like, sorry, the picture wasn't the most optimal drawing. Let's try that one more time here. It's obviously not to scale. Okay, something like that. Where this vertex here is 3, negative 8. This is the point 5, 0. This is the point 1, 0. This is the point 0, 10. Okay, we'll stop it here for now. I'll leave you with a little exercise, which is for g of x is equal to negative 2x squared minus 8x plus 24. So put g of x in vertex form. And let's just stop there. We've seen now enough examples of doing the rest of it. And I'll show you, there's a little small trick to finding the vertex of a parabola. I'll show you guys that as well in the next video. So let's stop.